Alright, welcome again. In this tutorial, we are going to talk about the applications of differentiation and what? Integration. So application of differentiation and integration. Alright, so we can apply differentiation and integration in different areas. Now today our focus is going to be based on the gradient of a tangent to what? A curve. The gradient of a tangent to what? A curve. Alright, the gradient of a tangent to a curve. So the gradient of a tangent to a curve. Right. So how do we find the gradient of a tangent to a curve with the help of differentiation? Let's say you are given a function in the form y equals 2x squared plus 9. Now, to find the gradient, when you differentiate this with respect to x, that one will give you the gradient function. Let's say it is at a point. So basically, we're talking about the gradient of a tangent to a curve at a point. At a point. Let's say it is at a point 2, 3. So what we do is we differentiate this with respect to x. So this is going to give us, using the power rule, we get 4x plus 0. This is going to still give us what? 4x. Now this becomes what? The gradient function. The gradient function. So when we differentiate respect to this, you are going to give us, it is going to give us the gradient of what? That curve. Now, when it's passing through this point, x, y, what we do is we just substitute the value of x into this, and that will give us the gradient. So the gradient will be equal to 4 times what? 2. This is going to give us what? 8. And this becomes the gradient of what? The tangent to that curve. Now, the negative reciprocal of this here will give us the gradient of the normal. So gradient of a normal to the curve of a normal is going to be the negative reciprocal of what? This. That, so it means that I'm going to get negative 1 on what? 8. Alright. So that is that. Let's take an example under this part. So we are saying that to find the gradient of a curve at the point x, y on the curve, you find the y, the x, using the appropriate rule. Either you are going by the power rule or the chain rule or the quotient rule, any of this rule that will help you to differentiate. Now, then we substitute x into what? The function, the gradient function. Then after that, the resulting value is the slope or the gradient of that tangent. Now the negative reciprocal will be the gradient of the normal to that curve. Let's take an example. So example 1, find the gradient of y equals x squared plus 3 all squared at x equals 1 on 2. So we are going to find the gradient of this curve, right? Now, how do we do that? We are going to differentiate this function here. So we have y equals x squared plus 3 all squared at x equals what? 1 on what? 2. So how do you differentiate this? Now, using the chain rule, we can easily solve this, or we can go by the short chain, right? So this, the normal differentiation using the power rule, this will multiply this, then subtract 1 from here, then you do what? You differentiate what is in the um, bracket. So this is going to give us 2 s squared plus 3, then times what is in the bracket. When I differentiate, I get what? 2x, right? So this is going to give me 4x x squared plus what? 3. You can go by the chain rule, right? Now let x squared plus 3 be equal to u. So u be equal to x squared plus 3, and this is going to give us what? Let's write this. So differentiate u with respect to x. So the u, the x will be what? 2x. Now, we said that let this u be equal to this. So it means that y will be equal to what? Y will be equal to u squared. So the y, the u will be equal to 2 what? U. All right. So the next one. So it means that the y, the x will be equal to the y, the u times the u, the x. Now, you see that we have the u here, the u here. It will cancel out to give us the y, the x back. So we have the y, the u, which is going to be, what is the y, the u? We have the y, the u being equal to what? 2u times the u, the x, which is what? X, 2x. So this is going to give us 4xu. But our u is what? To get 4x out, u is x squared plus what? 3. All right. So with this, we have the gradient function. So the y, the x is equal to what? This. We can decide to expand this, or we substitute the value straight into it. Now we are saying that at x equal to what? 1 on 2. So it means that our gradient will be equal to what? This is going to give us 4 times 1 on 2 to bracket half squared plus 3. And the result will be what? 13 on what? 2, which is going to be 6.5. And this is the gradient of what? The curve. The gradient of the tangent to what? The curve. So the negative reciprocal of this will give us the gradient of the normal to that particular curve. Let's try another example. Example 2. Example 2. Find the gradient of the tangent to the curve y equals x cubed minus 2x plus 1 at the point -1, 2. Right. So we are given the equation of the tangent to that curve. Solution. We have y being equal to x cubed minus 2x plus 1. So when we differentiate this, we get dy dx will be equal to 3x squared minus 2. Right. Now, at the point -1, 2, so the x coordinate is -1. So we substitute that one into it. So we get the y dx being equal to what? 3 times -1 squared minus 2. And this is going to give us what? 1. So that is that for this um, type of question. Now let's look at a different aspect of this concept. You are given an example. So example 3, the gradient. So in this case, the gradient function. So in this case, we are given the gradient function of the curve is given by 3x squared minus 8x plus 5 if 2 is the root of the equation of the curve find the of equation of the tangent. All right, now we are given the gradient function, right? So what happens? You see, so let's start, meaning that dy dx is equal to a 3x squared minus 8x plus 5. This is the gradient function. Now let's say we are given the function 2y equals 2x cubed plus 2. Now when you differentiate this, you get what? The gradient function to be 6x squared. Now to get this back, to get the function back, you do what? You take the antiderivative, which happens to be the integration, right? So we are going to integrate this, right, to get our function back. So let's see. We can write this as dy equal to 3x squared minus 8x plus 5 dx. Then we take the integral of both sides. This will go. Then we have our y being equal to, we are going to integrate this, right? So this is going to give us x cubed minus 8. So this is going to give us 4, right? 4x squared plus 5x plus c, because we don't know the constant, right? So we need to add what? C to it. Now, in this case, from the question, it said that if 2 is the root of the equation of the curve. Now, if 2 is the root of that equation, it means that when I substitute 2 into the equation, it should give me 0. If it is a root, it should give me what? 0. It means that with this, if I have this function here, s cubed minus 4x squared plus 5x plus c. If I put 2 into it, it should give me what? So f of 2 should be equal to 0. So it means that if I substitute 2 here, should be equal to 0. So what happens here? Okay, so we are going to get, when you put all these values, our c will be equal to negative 2. So at this point, the equation will be y equals x cubed minus 4x squared plus 5x minus 2. You see that when I try to differentiate this, it is going to give me the gradient function that we had in the first question, in the question that we were given. So this becomes the equation of the curve, right? So that is that. Thank you for watching.